Hi, my name's Adam Ostrich, and here I'm demonstrating a quick holographic shader I've built in UDK. The core functionality is based around a few simple material functions, but here I'm quickly going to demonstrate the capabilities of the shader. Initially, the core functionality is to have this burn-up technique, which is calculated using an if node and various calculations I'll get into shortly. This enables you to control it via matinee to turn the hologram on and off, and adjust the colour used for the burn in and burn out. So all of these functions can be adapted on the fly in gameplay or before gameplay, depending on how you've had it planned. We have various control options to change different aesthetic qualities of the shader. I have a gradient map functionality built in, which enables you to load in a gradient map that controls the colour based on the height value of the map, which is quite useful for elevation maps and such, where you might like to demonstrate the change in altitude via a different colour. The grid across the top is also multipliable, so we can have a large grid or a much finer grid, and again these colours can be controlled up here. This toggle for the gradient map is controlled via a switch scalar parameter, so that it can be turned on and off as a function and replace the core functionality with other information. Okay, so let's open up the shader. It's quite daunting to look at to start off with, but everything's nicely labelled. The core functionality we have here is a texture map which has an alpha height map and various kind of detailed maps in the red, green and blue channels. This is then multiplied by a parameter to change the colour and intensity and put into the switch, or multiplied by a gradient map, which, as you can see if we turn on the real-time preview, is simply a gradient, but in using the height map as a UV set we can adjust it to effectively be used as a height map. Here we have the grid functionality, which is basically multiplying a texture coordinate to multiply a detail map, which you can see here, to increase the scaling of the map. These are all multiplied onto other functionality, such as the power, which is the core of the holographic power setup. This power parameter is used to control the power of the hologram, so this drives all of the abilities beyond it. The power line scale increases the size of the line you see as it burns in. So if you have it halfway, you can increase it to make it thicker or thinner, so it's a very subtle burn in. If we make this more intense, turn that on. Increase the brightness. As you can see, we can kind of get some cool effects by increasing the size of the burn in, or just making a very subtle effect on the edges. This gives you plenty of control for accomplishing the effect you would like. In order to switch out the map and such, you can either use two different functions. You can either load in a pre-made map, or you can use what's used here, which is effectively just a plane with a height map that has tessellation built into it. This enables you to kind of either use any random height map and just plug them into the shader and have multiple options on a single plane, or you can have several different maps of different objects that you might want to put together. So if we go back to the shader here, the power line intensity and colour is what decides the colour. That's another parameter for customization. This pixel flicker is using sine waves and time nodes to create a flickering, almost digital appearance. If we increase the transparency of this, you can see these pixels flickering in and out to give a very digital effect. So if we shift that to nice colour, it gives the impression that hologram is slightly flickering out. This is then multiplied on top of the map, so we can have a subtle map overlay, so that where the power is low you still get to see part of the map. And then that is added on top, or looped in, with a band that pans across the map to imply either a power or a scanning system. This is simply just a panning texture, and we have the same panning texture being added into the tessellation map which enables the map to rise slightly and create this wobbly effect as it scrolls past. The tessellation is quite simple. It's a lerp between two different values that control the height offset, and this height offset is then driven by the lerp, or the alpha, which is my height map, with the panning texture over the top. The tessellation multiplier decides how tessellated the map is going to be. And this is the core functionality of the shader. So all of these parameters can be modified and changed, and should you not be running in DX11 and not have tessellation available, tessellation can simply be switched out for a geometry-based map system, which enables the same level of customization but not quite as much detail. The other advantage of tessellation is it's very simple. Should you desire, you can incorporate functionality to have the map grow up, so it begins as a flat plane and erupts from that, and other functionality like that. You can adjust it on the fly, so you're not reliant on the actual geometry you're providing it to accomplish the effect you'd like. I also have a pattern overlay here, which if I make it bright pink, you'll be able to see it a lot clearer. This enables you to have a overlay pattern to the map, so maybe a path or a moving target or something you could stick a panner into to make it scroll across the map. This enables you to have more depth and more purpose to the map. Obviously this isn't limited to just maps. You could load in any form of mesh and have the same technique apply, so you could have soldiers warping in, or objects, vehicles, anything like that. But this is just a quick demonstration of how the technique can be used and what you can accomplish with it.